So this is Ground Zero, Veale Gardens, South Terrace in Adelaide, where we're doing a pretty intensive plant healthcare program. Now, I probably wouldn't mind starting off saying and sort of commending Adelaide City Council, because this is actually a world first. We know it's a world first, not so much for the plant healthcare treatments and mulching and things like that we're doing, cultural practice type stuff for trees, but in the way that we're collecting data to understand better what we're doing to the trees, but actually sort of make that link between soil health and plant health. So one of the exciting parts of what we're doing with the data collection that we know is a world first is the way that we're measuring photosynthesis. So we're working, the last couple of years I've been working with Michigan State University, and we've been measuring photosynthesis across the board. So not just looking at chlorophyll production, how green the leaves are. We're also measuring photosynthetic efficiency and all the other components of photosynthesis. So we're measuring chlorophyll, Phi2, Phi-MPQ, Phi-MPQT, Phi-NO, and all those things are really important with understanding the whole process of photosynthesis. Photosynthesis is very complex, and it's not just recognising the fact that we can make the leaves greener on the tree. We need to understand that the whole canopy function is improving. So what we did in Veale Gardens to start off with, we've identified that there's been a whole lot of plant stress, tree decline, major tree decline in this part of the garden. We came in last year and we did a sort of a survey. We measured a whole lot of parameters to develop a baseline. That baseline is important because we need to know where we start off with the soil health componentry, and we also need to understand every component so that along the way we can change things and we know what we have and haven't improved. So what we did is we've chosen 30 trees, I think about 15 different genus and species, and you can see them fairly easily. All the trees that we're working on, the first thing we did was come in and identify our tree protection zone and our mulched areas. So what we did in the very beginning is we measured soil biology, soil chemistry, compaction, so using a penetrometer, compaction at different depths. We measured soil moisture, we measured sugar mineral density, we measured leaf temperature. Then we baselined all of our photosynthetic parameters. So we measured chlorophyll, Phi2, Phi-NO, Phi-MPQ, leaf temperature, relative humidity. And the system that we're using is really exciting because this is the first time it's been done in the Southern Hemisphere. And it's one of the first, well, it's the first type of project like this in arboriculture. So we know that because we've been working with Michigan State and I'm the only arborist in that group of people that has been base testing the devices. What's really interesting is that we can measure the photosynthetic parameters and we can use a software program that shows us the trends, and then we can put all of that data into a deep learning neural network, sort of like what Google and Facebook use to see what you're working out what you want to look at on the internet. We're using it in a way so that the computer can sort of take out some of the noise and really show us what's happening with tree function. So this is our third week working in the park, and the trees are already responding. I've done 3 lots of data set, and the canopy function has improved. Now, canopy function is interesting because not everything goes up. So your chlorophyll, the greenness of the leaf, obviously we want that to go up, and that's going up. But other processes in photosynthesis, like photosynthetic efficiency and Phi-NO and Phi-MPQT, they need to go down. So as the plant is photosynthesizing more efficiently, the leaf temperature lowers and the byproducts that come of photosynthesis, they reduce as well. So an unhealthy plant has a low chlorophyll, so it's not very green, but it also is struggling with dealing with the heat that's generated through the process of photosynthesis. So when you measure a sick tree, those processes are high in the scale and chlorophyll is low. So it's exciting. We're making that link. We're improving the soil health, and in turn the tree is improving in health. Now, visually, the trees are improving in health. maybe not so much for the layperson to see. I look at trees very closely every single day, and I can probably see it a little bit easier, but we've had other people that have walked through the garden and they can see that, you know, certain trees are putting on new growth and their canopy density is increasing, and all those visual componentries are important, but we're really interested in making that link between soil health and canopy function in a scientific level. This is important because the whole globe is moving towards urban forestry as a climate change mitigation scheme, whatever you want to call it. And it's very important. Our cities are prone to urban heat island effect. You know, the pollution in the atmosphere. Cities across the globe have lost huge amounts of vegetation, canopy density, canopy cover in all our cities, and that stuff is really important to mitigating climate change in the future. If we don't increase our canopy you know, cover and density and all those sorts of things, we're not going to be able to mitigate things like urban heat island effect and pollution levels and things like that. Now, if we're going to move into the future of intensive urban forestry, it needs to be more than just an aesthetic type way of looking at it. It needs to be more than just basic analytics. So we need to, you know, canopy cover is important, and we can measure canopy cover with, you know, satellite imagery and things like that. Those types of measuring practices are important, but it's really healthy trees that provide the benefits that we seek. When we talk about canopy cover and urban heat island effect and all those sorts of things, that mitigation offerings from the tree don't come from unhealthy trees. They only come from healthy trees. So we need to understand you know, what makes a healthy tree, what are all the different componentries, and we need to you know, have as healthier trees as possible that are, you know, producing microclimates. You know, health. You know, we're standing in the shade now, and you would assume that it's the sunlight that's, you know, not coming down on us that's keeping us cooler. But what's also happening is the trees are providing a microclimate, especially large deciduous trees like this. There's a small breeze, the trees are transpiring, they're drawing up water, and as they do that, you get evaporative cooling. And that microclimate is really important with urban forestry. And we need to start measuring that stuff, and we can do that now, and it's really exciting. So what we did is we did all of that analytics. Then we went through a process with Adelaide City Council to help them understand that we needed to make our plant health care treatments that we're doing last, you know, long term, and mulching and composting and removing the sod below the trees was a really important aspect. So you can see that all of the trees that we're working on have got quite large mulch beds, and they appear at the moment to have quite, you know, thick, deep mulch. But that stuff's going to break away, you know, as we bring in all the biology in the truck and we input that into the system, we stimulate it, all those microbes will break down all that carbon and reduce that material. In turn, the soil health will improve, our root to shoot ratio will improve, and in turn the canopy function improves, and, you know, we end up with healthier, more sustainable trees. Okay, so another important aspect to our measuring regime is carbon dioxide respiration. So as soil biology activates and it's breaking down all the carbon and growing and multiplying, they respire carbon dioxide. Now, it sounds bad that we're putting more carbon dioxide out into the atmosphere, but if you think about a tree growing, a tree is fixing carbon as well, so to build its mass. So if a tree is growing and fixing and sequestering carbon carbon dioxide out of the atmosphere to grow mass, to grow its wood, and at the same time you're getting carbon respiration from the soil biology activating and growing, it sort of evens itself out. But the carbon dioxide respiration stuff's interesting because what I did the other day was we've developed our baseline back last year of our respiration and our soil biology assessments from the lab, and so we developed a baseline. And what I did the other day is I came and picked a few key areas to see the difference. So I measured this spot here where you can, you know, you've got heavy compaction. You can see that's, you know, compacted. If we had the penetrometer now, I'm guessing it'd be something like 800 psi at 5 centimetres, which is incredibly compacted. You just don't get healthy root growth in those sorts of areas. You also don't have a lot of biological activity in that type of soil environment, and in turn your soil respiration values are lower as well. So what I did was I measured this area here in biological respiration, went over to the site where we had the piles of mulch, compost, and there's also some forest mulch material over there. And so I measured the respiration of the tub grinding material from the Adelaide nursery, some old forest mulch that had sort of broken down and reduced in mass and had been broken down by biological activity. I measured some fresh mulch that had come straight out of the wood chipper from the tree guys that didn't have a lot of biological activity. I measured, and then I also measured the sod pile from all of the sod that was removed from the trees. And what was interesting was the sod pile CO2 respiration was quite high. The sod pile was as much as the old forest mulch. The new forest mulch had a lower CO2 respiration value. The tub grindings had a very high CO2 respiration, and that's quite obvious, and you can also tell that because the temperature's high, and as microbes are multiplying and breaking down that material, they're producing heat, and so that's why a pile of material gets hot, because it's the microbial activity increasing. So by sort of measuring a few different piles by themselves was an interesting exercise. Because we'll use that information to look at what we've done here. I think I've done 3 samples of CO2 respiration on the trees that we're treating, and that CO2 respiration is increasing as the biological activity increases. So, you know, in a nutshell, again, it's all about data. You know, for us to go into the future with urban forest practices and methodologies, and to get the budgets that we need to mitigate climate change, we need to do things more scientifically. We need to show that we understand that, you know, healthy trees provide the benefits we seek, and we can only understand that through good data analytics, and then being able to collect that information and understand it, and then use that information for future generations to do a better job than we are now.